Hello everyone, welcome to yet another practice problem video of CSC 260. In the previous video, we have seen some arithmetic operations on 2's complement number system. In this video, I'll be showing you some arithmetic operations on 1's complement number system. So let's get started. Before I move on to the practice problems, just a quick recap just like I did last time. This time I will be focusing on the conversion between the decimal number and its 1's complement form. So at first I need to check if the decimal number which I am given is a positive or a negative one. If the number is a positive one, I just have to convert it to its corresponding binary form and perform the sign extension operation, and I am done. However, if the number that I am given is a negative one, I need to do a few extra steps. At first, I need to convert it into binary and then, as usual, perform the sign extension operation. Next, I need to perform the bit inversion. That is, I'll flip each and every one of the bits of the binary number I got in step 2. And that's it. I got my 1's complement form of the decimal number which I was originally provided. Unlike the 2's complement conversion, in 1's complement conversion, I don't have to add the extra 1 at the end. So this is the basic difference. In fact, this is actually easier than that. Let's look at some problems. So at first, let's convert plus 3 into its corresponding binary form. So like the 2's complement video, if I have a positive number and I am told to convert it into its 1's complement form, I just have to convert it into binary, and this will be the same as the 1's complement form. So the binary will be, the 4-bit binary will be 0, 0, 1, 1. This is my binary, and like I said, my 1's complement will be the same. So 0, 0, 1, 1. This is my 1's, so I'm writing it like this. For plus 4, my binary will be 0, 1, 0, 0. And my 1's complement will be the same. Let's add these. 1 plus 0, 1. 1 plus 0, 1. 0 plus 1, 1. 0 plus 0, 0. Since this answer is positive, I can directly convert this into the binary form, which is 0, 1, 1, 1. And likewise, my decimal will be plus 7. So I can write here plus 7. So is there an overflow? Like I mentioned in the previous video, when you add two positive numbers and I get a positive number, there can never be an overflow. So in this case, I added these two positive numbers and I got this positive number. So there will not be an overflow. Another way to check is that the range of a 4-bit 1's complement number system is from -7 to +7. As you can see, this +7 falls in this range, so there is no overflow and my answer is correct. So this is the answer and this is the decimal answer. So as you can see, my answer is correct. So is there an overflow? No, there is no overflow. In this problem, I'm asked to add +5 with -5. I know this is very easy to do it normally, but let's do it in the 1's complement way. First, let's convert +5 into its 1's complement form. So the binary will be 0, 1, 0, 1. And the 1's complement will be 0, 1, 0, 1. It's actually the same. You know the reason why. To convert -5 into the 1's complement form, first I need to write it as binary. So minus of 5. So 0, 1, 0, 1. This is the binary form. So minus, and this is 5. So -5. So to convert a negative number into its 1's complement form, I just have to invert the bits. So if I invert the bits, I will get 1, 0, 1, 0. This is in 1's complement form. Now I have to add these two numbers. Let's add. 1 plus 0, 1, 0 plus 1, 1, 1 plus 0, 1, 0 plus 1, 1. As you can see, this is a negative 1's complement number. To convert a negative 1's complement number to the binary form, I just have to invert the bits. So this was my 1's complement form, and now I have to invert the bits. So if I invert the bits, I end up with 4 zeros, right? This is my binary form. And since this was negative, I'll add a minus here. So if I convert this 0 into decimal, I'll end up with minus 0. So why did I write minus 0? Please remember that in 1's complement, I have two zeros, plus 1 and minus 1. Unlike the 2's complement, whereas I have only one 0. So this is minus 0. So in this case, there is no overflow because I'm adding two oppositely signed numbers. That's why there can never be an overflow. Meaning, if I add a positive number with a negative number, there can never ever be an overflow. Let's check our answer. So this is my answer. My answer matched and there is no overflow. In this problem, I'm asked to add minus 2 and minus 5 in 4-bit 1's complement number system. Let's find the equivalent 1's complement form of minus 2 first. At first, convert it into the decimal form, which is minus of 0, 0, 1, 0. For the 1's complement form, I will just invert the bits. 1, 1, 0, 1. For minus 5, I will follow a similar approach. So 0, 1, 0, 1. This makes it 5. And for 1's complement, 1, 0, 1, 0. I inverted the bits. Now let's add these two 1's complement numbers. 1 plus 0 is 1, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1 is sum is 0 and carry is 1. Now a very important step. We have an extra carry out right here. So if you remember in the previous videos, during the addition of 1's complement numbers, if we ended up with an extra carry out of 1, we used to add it back to this part. But in 2's complement form, we can discard it. But here, like I said, I'll be adding 1 to this part. So if I add 1, I'll get 1 plus 1 is 0, and then carry of 1, 1 plus 1 is 0, and then carry of 1, 1 plus 1 is 0, and then carry of 1, 1 plus 0 is 1. So this is my final answer. This is in 1's complement form. As you can see, this is a negative number, right? This is also a negative number, and the answer we got is also a negative number. So I can say there is no overflow since I added two negative numbers and I got a negative number. Now let's convert this 1's complement number to its decimal form. So first, converting it into the binary form. So I can write a negative since this is a negative number and bit invert. So 0, 1, 1, 1, and this is the binary. If I convert this binary into the corresponding decimal form, I get a minus of 7. So this is minus 7. So if you remember, the range of a 4-bit 1's complement number system is from plus 7 to minus 7. So this is well in that range. So I don't have an overflow. This is another explanation why. Let's see if our answers match. So as you can see, I got this answer and my answer is correct. Is there an overflow? No, because I added two negative numbers and I got a negative number as well. Moving on to my last example. Now I'll add minus 3 and minus 7 in 4-bit 1's complement number system. Let's start. For minus 3, the binary number will be 0, 0, 1, 1, and this is a negative one. The 1's complement will be 1, 1, 0, 0. This is the 1's complement number. Okay. For minus 7, this is minus of 0, 1, 1, 1. And for 1's complement, inverting the bits, 1 and 3 zeros. Let's add these numbers. 0 plus 0, 0, 0 plus 0, 0, 1 plus 0, 1, 1 plus 1 sum is 0, and a carry of 1. So like I said in the previous example, I will add this extra carry out to this. 0 plus 1 is 1, 0 plus 0 is 0, 1 and 0. So pause this video and think if there is an overflow here or not. Yes, there is actually an overflow here because I'm adding two negative numbers as you can see, but in the answer I got a positive number as you can see because the MSB here is 0. So I can say there is definitely an overflow. If I had normally added minus 3 with minus 7, I would have gotten minus 10. But if you convert this positive 1's complement number to its decimal form, you will get minus 5. So minus 3 and minus 7 is definitely not minus 5. So this is an overflow and I'm getting an error. So let's check our answers. So this was the last practice problem video of arithmetic operations on sign numbers. So before I end this video, I would request all of you to pause this video and give a quick look at this overflow condition on arithmetic operations on sign numbers. So after you go through this, I hope you will not have any more problems. So thanks for watching my videos. I will see you next time. Till then, please stay safe and take care. Thank you.